Biology Part 5. Carbohydrates molecules vary greatly in size but are not difficult to classify. There are three main groups, namely monosaccharides, disaccharide, and polysaccharide. The monosaccharides are simple sugars which have between 3 and 10 carbon atoms per molecules. The diaccharide are described as compound sugars and each molecule contains the two monosaccharide units pointed together. In a polysaccharide molecule, many monosaccharide units are joined to form a chain. The monosaccharides are normally classified according to the number of carbon atoms they contain. The most important types in living organisms are 3 carbon sugars called trioses, 5 carbon sugars or pentose, or 6 carbon sugars called hexoses. Within these groups, the various atoms present can be bounded together in different ways, often giving different chemical transactions structures even when the number of carbon, hydrogen, and oxygen atoms remains the same. These alternative structures are called structural isomers. One of the most important variations is illustrated by structures of glucose and fructose. Both of these sugars contain 6 carbon atoms and have the overall formula of C2H12O13. In addition, we can find it over there. Each molecule contains a chemically reactive double bonded oxygen atom, and that oxygen atom, which gives it its characteristics, chemical properties in the molecules of glucose. This atom is located at the end of the chain of carbon atoms, where it forms part of hydrogen, carbon, oxygen, and aldehyde group. However, in fructose, the double bonded oxygen is attached to the second carbon atom in the chain, forming a ketone group. These isometric alternatives give rise to 2 different series of monosaccharide sugars, each with slightly different chemical properties. The adose series includes sugars as glycerides, ribose, glucose, and galactose, which have the aldehyde group, while the ketose series include the dihydroacetone, fructose, and other sugars which contain the ketone group. Well, as we move around, we get ring structures of monosaccharide sugars. Most pentose and hexose sugars molecules can exist in the form of rings in addition to their straight chain form. This is very important to feature carbohydrates chemistry because the ring structures produced are needed for building up the complex carbohydrates. Powdered dry glucose exists mainly in straight chain form. However, when glucose molecules are dissolved in water, 2 different ring structures are formed as shown. These ring structures are more stable in solution, so that at equilibrium, almost all of the molecules are present as rings, with the straight chain of being relatively short-lived intermediate. By convention, the carbon atoms in straight chain glucose are numbered from the end nearest to aldehyd group.